Perfect. So really excited to present our speaker, Ruth Kikin Gil. So Ruth Kikin Gil is a design strategist that leads the responsible AI practices for Microsoft's security, compliance, and management organization. She's also co-creator of the guidelines for human AI interaction. And she also teaches design at the Human-Centered Design and Engineering Department at the University of Washington in our neighbors to the south, Seattle. Her career focuses on product innovation across devices, input methods, and platforms, including designing feature experiences for Office, creating feature scenarios in an incubation lab, as well as working on a strategy team. While doing that, she somehow found the time to apply and be granted for 16 patents. Super well accomplished. And prior to Microsoft, she founded a design agency, worked in startups, and also as a consultant. She is a Bezalel Academy of Art and Design alumna and earned her Interaction Design Master's degree from Interaction Design Institute Ivrea in Italy. So super stoked to have her come and share her knowledge with us today. So yeah, today's talk, Behind Every AI, there's a great human, how to design AI products responsibly and why that matters. So without further ado, I would like to hand that off to Ruth. So if you can share your screen.
Yeah, not so fast, you know how this technology goes, right? So you need to keep on talking. Just for a moment or two, you know, just about the song that we talked about.
Well, Mary's telling me to sing for us, and I don't have any songs right now.
Okay, here we go. Hi, everyone. True to the introduction, yes, I am Ruth Kikin Gil. And I want you to meet this person. His name is John McCarthy, and he's one of the forefathers of AI, as we know it. Sorry, I'm hearing all kinds of noises.
Amanda, could you please mute yourself?
I'm so sorry.
Oh, okay. So this is John McCarthy, and he was one of the forefathers of AI, and he's the one that coined the term artificial intelligence in 1956. And back then, he defined the subject as the science and engineering of making intelligent machines, especially intelligent computer programs. And ever since, we're all chasing this vision of super intelligent being that people built. And they built it so well that it's so much smarter and better than us that it just takes over the world and obliterates everyone else. But if you take a look at AI today and what it's doing, it's really just a fancy name for a group of technologies that are one-dimensional. And each one of them may excel at doing one thing, but their abilities is really limited to a specific context, and that context is provided by a human. And even more, most of the AI products that we're talking about, they are combining, it's not just one model, they're combining multiple models. And each one is also limited in scope. Each one predicts a set of predictions and a set of results, and then feeds these results to the next algorithm in line, right? And behind all of that, there's someone, a person that orchestrates everything these algorithms do and defines what's the ultimate goal for everything. And when we're looking at the differences between traditional programming and machine learning, you can see how they differ. And in traditional engineering, the code is a definition of rules written by a person. And this code is applied to the data and uses the rules to calculate an answer. And the results are predictable and repeatable. In machine learning, the algorithm, which we also call a model, analyzes past data and resulting answers from that past data, and then produces rules that we couldn't figure out traditionally. And the human collects the data and gives the model a group of examples. And let's take a look. So if I want to train, this is called training. If you want to take to make a model to be able to recognize muffins, a very important task, right? We show them a lot of different pictures of muffins and tell them muffin, 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 until it learns what muffins look like. And this is called training. We also, part of it is showing it things that are not muffins, but we'll not get into that now. And the result is this, right? Where we can ask the model, is that a muffin? Is that a chihuahua? And it can give us the results for each one of them with a certain amount of confidence that this is actually a muffin or not. And you can see that AI is everywhere and the market share is rapidly growing. So if in 2018, the market share was $20 billion, the prediction is by 2026, it's going to be $200 billion. That's huge, right? And it's also less than 5 years from now, which means that if you're not already working on something that is connected to an AI or is some kind of AI product, you will do that very soon. And AI can do really exciting things. You know, it can generate human-like text. So if you want someone else to write your next book, there you go. Or it can create visuals. It can create weird things that you could maybe not think about them. In this case, it can translate, you know, hand-drawn sketches of components and turn them into fleshed out high fidelity prototypes. In another case, Jordan Singer is a designer, a developer, created a Figma plugin where he trained it on a model called GPT-3, a language model. And the result is that you can type in all kinds of things that you wanted to do, and it produces visual results. So in that case, it says, hey, I like a website like stripe.com that is about a chat app. And this is what stripe.com looks like. Sorry. And this is not what stripe.com looks like. This is what it looks like. And then this is what the plugin spewed out, right? Which is pretty impressive. You can also edit your video by editing the text, you know, just taking out bits and pieces of the text and the video gets shorter and shorter. Or you can create your own deepfakes for only $29.99. All this beauty is yours. And it can do many, many more exciting things, right? From identifying security breaches to skin cancers to developing drugs. The list is endless. But as we all know, things are not that simple, right? And there are challenges to design for AI-infused systems, and let's unpack some of them. And the first one is that AI is a probabilistic and prone to errors. And I don't know, you're from the area, you might remember 2 years ago, everybody talked about how Seattle is going to be blown by the mother of snowstorms that the area ever knew. And everybody really panicked, and you know, you couldn't find kale in the stores because this is Seattle. And everybody waited for this huge disaster, right? And then snow fell, and about 3 days later, it went away, and we all survived, and it was okay. And you can think about weather forecast as a metaphor for AI systems. It looks scientific, which it is, and therefore it's reliable, right? Not really. And we need to design for this tension. And we need to convey its predictions in a way that will communicate clearly to the users that this is not the absolute truth, and that what they see is probably right, but we're not 100% sure about it, right? And this is something that both weather forecasts and AI systems today don't do very well. Let's admit it. And the second thing is that AI learns and grows and changes over time. And this is really the big promise of AI, right? You build something and you put it out there, and then it grows into something wonderful. Well, it's not always that wonderful. Sometimes it's tragic, like in this case where a journalist got pregnant, she was excited, started posting on social media, like everybody does, and then started seeing all these ads about pregnancy. And then at some point, she had a miscarriage and she lost her baby. And she kept seeing those ads. And she told that website, I don't want to see them anymore. And then the website, as a response, said, oh, well, she doesn't want to see baby ads anymore, pregnancy ads anymore. She must have had a baby. So it started showing her newborn ads and baby products, which made everything worse, right? And the thing that I want to leave you with in this story is that you can't just put something out there and say, oh, okay, now I'm done. You really have to keep monitoring it, really have to keep thinking about the thing that you put out there in the world and be responsible for the results of what it's doing. The common discourse about AI is that it's a hard technical problem. The truth is that it's also a hard human problem because it touches everyone in society. You, me, everyone. And the question is, what will help us take a human-centric perspective when we are designing AI systems? How do we do that? But first, let's take a look at what happens when things don't go as well as expected. And this is Joy Buolamwini, a researcher and founder of the Algorithmic Justice League. Let's watch.
Camera, I've got a face. Can you see my face? No glasses face? You can see her face. What about my face? Well, I've got a mask. Can you see my mask?
So that was kind of a milestone in Joy's career, in everybody that's in the AI realm. What she discovered by doing this simple exercise, she was playing with the facial recognition technology and wanted to create this funny little experiment. And she discovered that the algorithm doesn't recognize her face. And when she put the white mask, it does recognize her as human. So she started with others this gender shades project. And what that project was looking at was how accurate are the common facial recognition technologies are. And what you found was that in some cases, the difference in accuracy of recognizing someone who is a male with white skin and someone who's a female with black skin is 34%. And this is talking about erasure, right? Third of the Black women are not recognized. Think about it. Kate Crawford, who is a well-known researcher in the AI and the ethical AI area, said, "What is interesting about training datasets is that they always bear the mark of history, that history will be human, and it will always have the same kind of frailties and biases that humans have." So here's another example. Facial recognition. This man was wrongly accused by an algorithm that he robbed a jewelry store. And the police came to his house in the middle of the day and just took him away. And when you're looking at kind of the evidence why that algorithm thought that that was the person, you can't really say anything but the fact that they were both Black, because they don't, the picture that the shop had as on their security cameras and the picture of this person are not even resembling each other. And that arrest was made based on that algorithmic decision. And here's another example: lack of fairness and inclusion in ads. So Latanya Sweeney, she is a Harvard law professor. She discovered that her name invoked ads that imply that she was a criminal, she has a criminal record. And she discovered that in an interview, and the journalist was sitting across from her, and he was Googling her while the interview went on, and he said, "Oh, okay, but what about your criminal record?" And she said, "What?" And then he showed her, you can see here all those ads that imply that, yeah, she has something in her past, right? And then she dove deeper into that and did some research and found out that names that are typical Black names invoke those type of ads, and white names don't. And then there's another aspect of that. If you are men and women, you'll see different ads, right? And men see more wealth building ads than women. And white people see more wealth building ads than Black people. So they will see more ads around buying houses, and Black people will see more ads about renting apartments. So even in the access that people have to opportunities, right? Some systems are really biased. And then there's driving cars that don't recognize people with dark skin. You know, this is a life-threatening emergency right there. Or a skin cancer and a skin disease app that tries to do good, right? Like they're trying to save people by just taking a picture of something and diagnosing it. But if it can't diagnose cancers on dark skin, it means that big parts of the community, big parts of the population are not being diagnosed. And this is not a new thing. I don't know if you noticed, but there were already articles about similar things from like 3-4 years ago. And then problems with recruitment, which is biased, systems that recognize men better than recognizing women and young children and old people and people with accents, or the fact that we're lacking transparency in AI assistants, like in Maverick here. Or when another thing to think about it is that algorithms can be fooled. They can be hacked. You know, there are all kinds of very sinister ways to do that. And here's one. You can see this very benign stop sign and someone put some stickers on it. But actually what these stickers do is they hack the vision system of computer system algorithms. And instead of seeing a stop sign, what the system sees is that the speed limit is of 45 miles per hour. And that is very different, right? So this is not the problem, the way I see it, right? The big concern is really that we are going to perish from neglect because we're not paying enough attention to all those harms that happen to the things that we release to the world, because we're saying, okay, that was such a great technological idea. I must pursue it, you know, because no one else did it before. So kind of the technological hubris right there. But if we do not pay attention, then we are all going to be in a very big problem very soon. And companies all already find problems with responsible AI or lack of responsible AI. So 9 in 10 organizations across countries have encountered ethical issues resulting from the use of AI. On the other hand, when interactions and brands and features are considered to be ethical, it's the other way around. People tend to trust them more, and people think about them in a positive way. And NPS score, which is one of the ways to assess business success in a very simplistic way, goes up like 44 points is a huge gap. It's a huge difference. Melvin Kranzberg said, technology is neither good nor bad, nor is it neutral. And because this is the situation, right, we have to think about principles and value as something that is guiding us. This is the focus of responsible AI. You're working from values that we all share, right? We all believe in. So we have privacy and security, fairness, transparency, accountability, inclusion, reliability. All of them are different facets that are very important. These are Microsoft responsible AI principles. And if you look at other companies that have developed all kinds of value systems like that, they're all very similar to one another, because this is really the core. And when you are practicing responsible AI, it's not enough to have those principles in mind, right? You really want to put them into action. And responsible AI pillars are that they are human-centered, they're principled, we talked about that, collaborative. So these are different disciplines, different perspectives working together. It's proactive. We don't wait until something happens. We really try to find out about these things beforehand and kind of make sure that we are delivering something that is more positive than negative to the world. And then everything is contextual. There is no one list of things that, oh, if you do this, you're fine. If you do this, don't bother, right? It's all about the scenario and the use case. So if you want to use facial recognition technology to log into a computer, that's totally fine use case, right? But if you want to use the same technology to identify people in protests, in demonstrations, and then throw them to jail because they were protesting against the government, totally different story, right? Probably you wouldn't want to do that. I hope so, right? So I want to iterate. Responsible AI is not just about data science, it's about all disciplines working together. And I just had a conversation this week with someone, and she told me, yeah, but I understand responsible AI. It's all about, you know, figuring out things in the model. And I said, no, 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 this is a misconception. We really have to look at the end-to-end scenario and look at the different parts of this scenario and recognize what are the harms that we are causing by these different parts, and who are the people that we can involve that can, one, recognize those harms, and two, try to find mitigations to them, right? because a data scientist, a designer, an engineer, user researcher, each one of us will have a different way to look at things, and they will look for ways to mitigation in their domain, right? So at the end, after considering all that and considering all the different stages of the product lifecycle, we get something that is really being reviewed end to end. And for each stage of the product lifecycle, we have different tools. I'm going to talk later about the Human AI Design Guidelines more in depth, because this is a design crowd. But I also want to say something about activation of responsible AI overall in an organization. So you need a few kind of building blocks in there. You want to build RAI leadership, right? So in my organization, I'm part of that responsible AI RAI leadership. You need to understand research. You need to understand what people need in terms of training, education, how to create this RAI literacy across your organization. And then maybe this is the reason for everything, is implementing in product teams. And how is that done? When you are working on a new product, you're trying to assessing the impact of the AI on the world, on the users, on society, really giving kind of a 360 scrutinizing of what's going on in that product. And then create a responsible AI release plan. And what are the ways in which you can mitigate the harms that you have found? And then after you're released, you need a plan for how you monitor incidents, how you monitor things, because maybe the one probabilistic thing in this world, one deterministic thing in this world of probabilities is that we are going to be wrong. So what are we doing when we are wrong, when things go awry? So let's go back to the Human AI Design Guidelines. The good news is that issues caused by AI frequently can't or don't need to be solved by algorithms alone, but by good design that mitigates them. And a group of people from across Microsoft, in Microsoft Research, Office, others, we came together and we said, okay, how do we make that connection between the high-level principles that we all think are great and every day's work? And in the design realm, we started this project that resulted in the guidelines for human AI interaction. And these guidelines are a distillation of 30 years of industry and academic research. So we took dozens and dozens of different research papers and articles and from academia and industry and kind of funneled them down into these 18 cards or 18 guidelines. And each one of the guideline, you can see that there are 4 groups here. Each one of these groups is has the guidelines that are more relevant to this phase in the relationship between users and the system. And if you want to read exactly how it's done, there's a Kai paper. But really what's important are the guidelines and what they say. And so let's do that, and I'll give you some examples. So the first part is initially what happens then. In this example, making clear how well the system can do what it can do. So this is all about context setting, right? This is Facebook is saying, hey, these are people that you may know. It's not, it doesn't know if I know it or I don't know that person, but it's using a very humble language right there. Or on the right, you can see Zoe, who's a social bot. making typos on purpose. Why? Because it knows that at some point it will make mistakes. So let's prime the user to understand that this is not a perfect system. And then what happens during interaction? I believe many of you are familiar with this CEO query. And this is about mitigating social biases. So what happened was that you would type CEO as a query, and what you would get was this collection of mostly white, male, middle-aged. And the Bing team wanted to think differently about that, right? It says, okay, maybe we can do better here. So they pulled together researchers and designers and data scientists and worked this. And now, you know, back then, if you wanted to see something like a female CEO and Black CEO, you can do that by going into the subqueries. But today, if you type CEO, this is what you get, or some other subset of diverse faces and ages and voices. And if you still want to see a male CEO, you can do that, but you have to go through the subqueries. And now, my favorite, what happens when we're wrong? And one way to think about it is, how do we support efficient correction? Which means that if the system is wrong, how can we help users regain control? So in this case, you can see I just added an image to PowerPoint, and I get this alt text. And the alt text, which is great for user accessibility, you know, people who can't see what's in the picture, they can use the screen reader and it will tell them what's going on in the picture. But sometimes we don't get it right. And sometimes it's not what the person meant, the one that created that slide. So we enable people to go and edit that alt text and change it into something different. And then what happens over time? In this case, it's about encouraging granular feedback. And feedback and creating feedback loops is one of the most important things when you're talking about AI systems, because it does, one, it helps the system learn from users' interaction. And if it can't infer from the interaction, it can ask specifically and say, let's look at the left, there's Microsoft Viva. It shows me my today's meeting, and you can see that there's an employee town hall, and then it found 2 emails that may be related. Again, this humble language, and I'm looking at it and I can tell it, well, it's not related, right? And then the system learns. And then when you do that, you gain 2 things out of it. One, you learn, the system learns and gets better, hopefully. Of course, you need to put things in place to be able to take that feedback and change your, retrain your algorithms. But the other one is when someone is interacting with you and giving you feedback, they're investing. They're investing their time and mind share. And then it's more likely that they will return to your product. Of course, if you made sure to give them feedback and understanding of what you did with that feedback. And when after the guidelines were created, we were curious to know, how do users react when a guideline was applied and when it was not? We call it the violation. And to measure the impact, we ran studies that try to assess the guidelines' effect on business goals and success. And we took the users through a series of experiments to understand how the guidelines influence the perception of products. And in each experiment, we asked users to evaluate features when guidelines were applied or when they were violated. And what we found was that the features that apply the guidelines consistently performed better in metrics that are connected to successful products. People tended to trust them more, felt productive, they felt in control. So if you're interested in any of that, pay attention. So after we had the guidelines, we said, okay, we think they're good. We think they work. We wanted to put them into action, right? So we created a workshop and an experience of auditing features. And the audit had basically 3 parts. The first part is taking a look at the guidelines and defining for this specific feature, what's the core set of guidelines that is important for that feature. And then doing some exercise practice with a sample scenario. And the last part is what we call a bug bash. And if you're not familiar with the term, it means that we are going over a scenario in whether it's a build or a prototype or whatever, and filing bugs. Everyone in the team do that at the same time. And the idea is to find as many bugs as possible. And it's important to kind of narrow down the number of guidelines that you are defining as your core set, because there's only so much resource time that a team can work with, right? That can dedicate to something. So 18 is a little bit over the top, but 5, that's a different story, right? This is something that a team can handle. So even the discussion about what are those 5 is really meaningful. And when the team decides that, okay, these are my top 5 guidelines, it means that they are committing. They're committing to put people and resources and time, fund it. It becomes part of how you create your feature, how you create your product. So let's look at some example. What does defining core guidelines mean? So let's say that you are working on something that has to do with notifications, then timing services based on context is very important, right? I'm sending an email to Michaela and I said, oh, I sent this attachment, but I didn't, right? Great time to notify me about that. If I'm working on a recommender system, this is making clear why the system did what it did is very important, right? I can see all these documents that Office has recommended for me, and I'm saying, oh, but why was that recommended? And then I get the explanation, oh, so-and-so just mentioned you. And I might not agree with that, but at least I understand it. And when you understand something, you tend to be also more forgiving if it did go wrong. So we don't start dive immediately into the 5. We define 10 and then do that walkthrough. And this is exactly what we did. We're doing this walkthrough through a scenario that we defined. And as a team, everybody who's part of that feature team participates, or at least the core people. And based on everything that people know about those guidelines, we start kind of putting those notations, those numbers of guidelines on the interface itself. And then the people who did that can explain why they thought that, hey, this is a violation of guideline number 1. And there can be a discussion around that. And through this discussion, people learn how to think about identifying these issues through the user experience. And after we go through that, each person on the team defines what is their core 5. What are the ones that they think are most important? And you can see that they differ. These are real examples. you can see that they differ from one another. And then this is where another round of discussion comes in. And through that discussion, again, people are able to really clarify to themselves and to others what are the things that they think are important. And when the last part of everything is that we all vote for the top 5, and that becomes the core set that the team works with. And when they build new features on top of that feature, and when they change things, these are the things that they keep in mind. And of course, after this stage, like I said before, we have a bug bash. So everything becomes a bug. Every violation becomes a bug. And you can see that we are tagging them with the right tags, the number of the guideline and rise, so we can go and make sure that, hey, we covered all the things that we wanted to cover. And now we're ready to ship something that is better than it was before. So to wrap it up, AI is awesome, but it's also a hard human problem. And we really, really need to pay attention or, perish from neglect. And to achieve that, we need to work from principles and from values, because there will always be biases. But once you start choosing them wisely and you say, yeah, I know, but I want to make sure that my system follows these values, then you are taking control of these biases and making them work for you. And, people talk about AI as the new electricity, then responsible AI is like the insulation tape. It's the plastic wires around the real wires in there. And it makes sure that, no one gets hurt, that the power is there. It really fuels all the right places, and it goes to the places where it needs to go. But no one gets hurt as a result. Now, if you have any questions, or let's open a discussion.
Awesome. Thank you, Ruth. Let me just see if there's any questions so far. Is there any questions, anyone? There isn't anything in chat at the moment. Ooh, we do have a question around where can I get the cards? Where can I buy them or print them out even?
Yeah, so they're in the resources that I shared. There is a link to where you can see all of them. They're out there. If you can just look for guidelines for human AI interaction, Microsoft. And you can even print them. You can even print them in Chinese if you prefer. So there's a lot of information online. I can.
Ooh, did someone?
They're free. You can't buy them.
Evan asked a question around, is there a risk that we will change what we think in intelligence it to detriment of the human?
Maybe the person who
or Evan, do you want to jump in?
Yeah, Evan, feel free to unmute yourself and ask your questions.
Sorry, yeah, that was a beautiful talk. I'm just wondering, like, just because it's a question that's been on my mind for about 20 years.
I'm going to solve it for you. Don't worry. Yes.
Go ahead. So,
Yeah.
and I meant, sorry, and my bad, I typoed the question, but is there, so first of all, Ruth, thank you so much. Beautiful, beautiful talk. Like, I just really enjoyed that. Is there a risk that we'll change what we think intelligence is? So that it's sort of to the detriment of humans. Do you know what I mean?
I think that this is a very deep and complex question, and I can give you my version of an answer for that. I think intelligence is many things, right? It is something that has to do both with your emotional capacity and an intellectual capacity. And when we're talking about AI, there are different types or different levels of AI. The one that all the examples that they give here are what we call, and this is all we have right now, basically, is what we call narrow AI. It means that it has a very specific function. It needs to be given a context, a specific context. A person has to do that, a human has to do that. So this is level 1. And then there's another tier, which is the human level AI. We're not there yet. The predictions, there are predictions by the end of the century that will happen. But right now, and AI is not one technology, it's a set of many, many different technologies. So people, but with the kind of how these technologies develop right now, it doesn't look like it's going to make the jump yet. So we don't know. And then beyond that, there's the super intelligence. And this is when machines become better than humans. You can ask what is better, but that's basically it can do, when you were saying human level AI, it means that it can do anything that a human can do, like the best human can do. Okay, not your average person, but really the geniuses. This is the human level AI. And when we are talking about this tier, it really is about the connection and the combination of both intelligence and emotions and creativity, and really becoming something that is well-rounded. I think that we're very, very far from that. I think that maybe we can come up with something. I mean, there are so many experiments about sensing emotions or about being able to tell if someone is sad or happy or anything. It's very, very problematic overall, also from the responsible AI side, like how sometimes people themselves don't know how they feel, and sometimes they don't want others to interpret how they feel. And we have people on the spectrum that the way that they express their feelings might be very different from neurotypical people. So when you're saying, and people get each other wrong all the time, right? We think that we know someone, and then we discover we don't. We think that someone is you know, laughing at our jokes, but they're laughing at us. It's so complex. So when you're asking, are we going to change how we define intelligence? I don't know if that matters, because it's when at the end, it's about what are we doing with all of this intelligence? You know, in my mind, you don't have to be the smartest kid on the block to create something wonderful, right? You have to have that, and there are people that are, you know, genius savants, so that they are idiot savant, sorry. They can do one thing in an amazing way, but other things they have no control of. So, you know, how do you define, why is it so important to define intelligence versus contribution to the world? And how do we contribute and what do we do with it? So.
Thank you.
Yeah, probably did
Awesome.
not answer your question, but.
I thought that was very meaningful, Ruth. I probably have more questions afterwards, but we have a question from Boris around what's the most rewarding examples you have for applying RAI, and if you have an example of what was the hardest thing to do when you were applying RAI.
It's a very good question. I think that the hardest thing is when you look at something and you say that that shouldn't ship, right? After you create something already, and then you kind of scrutinize that. This is why we're always saying, yeah, before you start, when you just have the initial idea, start working on that impact assessment and really figure out what's the impact or what are the possible harms of that thing that you're building on the world, and start there. But if you didn't do that and suddenly you are faced with a reality that you're saying, well, actually, this shouldn't be out there. This is very hard. It's not easy to say, and it's not fun at all. But on the other hand, when the fun part is when you're seeing things and you are able to, I don't know if to fix them is the word, we use the word mitigation, because you can never fix things to the full. But you can improve things a lot. You can improve things a lot with changing the user experience, or making things that you're looking at it and you say, okay, now people can understand. I mean, things like transparency, I don't think that I stress that enough in the examples, but being transparent is super, super important. It's one of the most important things, because some of the models, right, they are built in a way that no one can understand how they made their predictions, how they made their decisions. Like I said, there are many different technologies, and not all of them are transparent the same way or transparent at all. And even the data scientists that build it don't necessarily know what's going on, right? So when you are able to explain tier one is that the data scientist will understand. Tier two is that the designer will understand what the data scientists understand, and then can explain that to the users so they can have more control. I think this is very satisfying. You know that you're doing the right thing there.
Mm-hmm. That makes sense. Just how we communicate to the different parties.
Yeah, and talking about transparency, this is another thing that we need to remember. It's not just about data science. Think about documentation. If there are content writers in the crowd, think about the language of UI. I think that for a lot of people on the design side, it's like, duh, right? Of course, we always have to do that, but it's not that obvious to others, and especially the importance of these things in the AI context is not as obvious.
All right. Thank you, Ruth. I don't see any last questions in chat. And I know we have 1 minute left, so there's a lot of praise in the chat. I don't know if you can see that, Ruth.
No, not really.
a lot of love in the chat. So a lot of hand clapping and whatnot. But thank you so much for your time, Ruth.
Yeah, you're most welcome. That was nice. And I'm glad. I like the hard questions that I don't really have answers for, because it makes me think more. So hey, that's intelligence. I don't know.
Cool. So I think that wraps up the talk portion of this event, but we also have a networking portion if anyone's interested. Right after, Dave sent an email to the group via Meetup, and it should be in your inbox. Cool. If there's nothing last minute left, thank you so much, Ruth. Thank you everyone for joining, and I'll see you next month.